Okay, let's get started with this demo. So here we have our own application, which is being served at demo.diagnostic.com on port 8081. It's running in a minikube on an EC2 instance. And for this demo, what we're going to do is break this application and troubleshoot that using our own platform. And this, our platform where we will build the workflow to troubleshoot this application is going to be at dev.diagnostic.com. And the first thing we need to do is create a workflow to troubleshoot this application when an alert comes in. So let's get started with that. We click this button, create a workflow, then choose AI Assist. And here we're going to create a very simple task first that's simply printing an alert. Let's do that. So we'll call it process Grafana alert. It's going to be a Python type task, and we need to add an input, which is going to be of a type dictionary. And it's going to be called, essentially going to print the payload of the alert from Grafana. And so let's just do the print here. Let's save this task. Okay. Now let's head over to Grafana here, and you'll notice that there are a bunch of alert rules here. There's only one that is active, and right now it's probing for an endpoint, and it all looks good here. So let's take a look at these alerts. It's this number 3 here, and we need to actually edit the contact point associated with this, which is a webhook. So every time this alert fires, it's going to invoke a webhook, which is in dev.diagnostic.com process observability event. That's the endpoint. And in this, you'll notice that there is a task ID in the end, and it's the ID of the task that will be executed in Diagnose when the alert comes in. And we have to replace this with the ID of the task that we just created that's going to print the alert. All right, let's save this in Grafana. We can test this, so let's just hit this test button and send a test notification. And as soon as you send it, what you will notice is that this task gets executed and it is printing the alert payload. So you can expand this here to see what it printed. This is the test alert payload from Grafana. Okay, so let's shrink this, collapse it, and then head over here. And now what we want to do is break our demo application, and the easiest way to do that is by deleting a service within our microservices cluster. I'm going to delete Elasticsearch. That's the database we will use. So I'm just going to delete that. So the pod is terminating and it's gone now. And if I refresh this, this application is not going to be reachable. So let's head over to alerts in Grafana, dashboard, and let's see to it that the alert is firing. So it looks like this endpoint is unreachable now. It's down. And in hang on a second. So let's resume the evaluation of the alert, and now it's firing. Let's see that this got invoked again. So as you can see, first time we executed this task was when the first test alert was set. The second time it is due to the real alert that was set. So we can see what the real alert payload looks like. So it's got all this probe failing, and it also has the endpoint is down. It tells you which endpoint is down and so on, right? So now what we're going to do is, let's hide this execution list. Now we're going to switch to agentic mode, where you just flip this button, and now you can freely interact with an agent in natural language and build this workflow further. So the first thing I'm going to do is if there is a ticket with this exact title, because we usually keep track of all these alerts by the alert name, and we open the same ticket again and again and dump all the information, and when the alert goes away, we close the ticket. So we're going to fetch that ticket first. So let's do that. I'm going to copy that alert name, and let's ask AI, can you look up that ticket with that exact same title in Jira and give me the ticket ID or URL? And if it's not found, then just create that ticket, please. Maybe this is the first time we are getting this alert, right? So there you go. So this is our task, and it created a Jira ticket because it didn't exist earlier. Here's a URL to that ticket. Now let's see if we can extract the endpoint from the Grafana alert, because we want to put that in the ticket as a comment. So it took the payload and extracted the took the ticket URL, and now it has a script to dump that endpoint in the ticket. Awesome. So it has updated this. So let's go and check our ticket. Yeah, so it was added as a comment here. The affected endpoint is this. Awesome. So let's go back to our workflow and continue building this workflow. Next thing I want to do is, let's extract the IP address of that endpoint, because that will tell us which EC2 instance is serving it. And then we can log into that instance and do some troubleshooting, gather more information, and put that in the ticket as well. Okay, so now we have the IP address. Let's tell it that this IP address is of the server that's running in the minikube. That's running the minikube, and now we can check to see if minikube is running actually, or is minikube down. Because like we simulated a specific error here by deleting a pod, but in reality there can be all kinds of issues. So we have to systematically troubleshoot it by checking to see if the instance is up and running, if the minikube is up and running, if all the services are up and running, and so on. So it just checked to see if the minikube is up and running. It looks like it's running, and it added that in the ticket, as you can see here. So if I refresh it, yeah, that's where it is. All right, so now let's go back to our workflow and continue further. Can you get the pod status of all the pods running in the namespace DagKnows in this minikube? And let's add that to the ticket as well, the code block. If I don't specify code block, it usually just adds as plain text. And I don't like that, so the more specific you are, the better. Great, so now we have all the pod status. Let's verify that it was added to the ticket. Nice. Yeah, we should also get the resource consumptions of all these pods at the same time. Who knows if a pod is consuming some resources and it just went out of memory or something. Okay, so we got that, and that was also put in the ticket. Now let's fetch the logs of a service called settings, because that's the first service that gets affected when the Elasticsearch goes down, and we want to fetch that's the first usual suspect in our setup. So we're going to just fetch the logs from here, check to see if there are any errors there, which we did, and looks like there is a bunch of logs here. First, let's add these logs to the ticket, and then we can take a look at the logs. You do notice some errors here, the main error being failed to resolve Elasticsearch, because Elasticsearch went down. So if Elasticsearch went down for any other reason, this is a go-to place for us to search. Let's add these log lines to the Jira ticket. Okay. So now it created a script, added those log lines to the Jira ticket, but it did something foolish. It took the log lines and created a variable inside the Python script here and simply assigned that array. But our intention was something different. What we wanted to do was take that log lines as the output of the previous script and feed it in. So occasionally you may run into such issues, but the good thing is that you can quickly edit this and fix it. So I'm going to add log lines as an array input here, which will be consumed from the previous task, and I'm going to remove this hard-coded variable here. All right, so let's save this. That makes the task reusable. Let's also ensure that the logs were added, and there it is, a bunch of errors, a bunch of Python exceptions, but main thing to look at is failed to resolve Elasticsearch. Right, so now we can say that if there are error logs that contain that specific string, then we know what to do. We need to restart the Elasticsearch, right? So we can codify it that way. We can add that to our workflow, saying if you parse all these log lines and find a string like this, maybe it's worth restarting Elasticsearch. And we can give the precise command to do the same. So kubectl apply -f elastic.yaml in a specific namespace. Okay, we're going to execute that command on that minikube. So let's ask it to do that and wait for it to finish it. Okay, looks like that was done. So if I refresh this, you'll notice that Elasticsearch was created. So let's this is the output after executing kubectl apply, which is expected, and that was added to the ticket as well, as you see. So if I go to our demo application and try to refresh it, it is still giving us 500 because there is one more thing that we got to do here, which is start the settings service as well. So let's do that by asking it to start the settings service by running a similar command, kubectl apply -f settings deploy.yaml in the namespace DagKnows. So there you go, we've got some output here, and looks like that was also added to the comment and you can see that was added to the comments. Okay, so now if I go ahead and refresh our application here, it is back up. So seems like we resolved the problem. So this is an example of where we took an alert, and we remediated the problem. But while doing so, we codified the entire workflow and made it reusable. So let's resume the evaluation of our alert. Right now it's all good, normal, because it's all back up. Let's ensure that the dashboard is also showing that the endpoint is up. That's good. Now, in order to turn all of this interaction into a reusable workflow, we have a special button called tidy up. If I hit this button, what it does is it's going to extract all the inputs that are unassigned and bring it all the way to the top. It will also title everything properly. It will also add descriptions to the tasks and so on. So it's essentially tidying up that entire interaction that we just had. So let's hit this button and see what we get. And it did pull up a bunch of inputs that were unassigned. For example, project key is an unassigned variable. Issue title is also an unassigned thing, but it doesn't need to be. We can extract values from the alert itself and assign those values to this issue title and project key and so on. Or we can hard code these values if we don't need to feed these every time. So let's switch back to the task view here. So I'm going to turn off this agent view and go back to the task view. And I'm going to just show all the input outputs and edit this guy. So here I want to get rid of issue title. Let's do that. And then I'm going to simply add issue title as some field extracted from that alert payload. Okay. So that's done. That's great. Now even project key, we don't need to supply it again and again. I'm just going to hard code it to DD and get rid of that as an input. So all we are left with now is this payload from the alert. So now we have this running. That's great. But now what we're going to do is break that thing again. And this is just to show you that if I introduce that issue again, I don't have to interact with AI to build workflow. That workflow is already built. Now it will automatically get executed upon that alert. Okay, so let's break Elasticsearch again. There you go. And resume the evaluation. It is now firing. The alert is firing because we introduced the problem. And you will notice that the executions, the task will get executed automatically at this point. Okay, so let's just wait for it. And there it is. So an alert came in. If I refresh this, I'll have the entire workflow execution in one place. Looks like the application is back. That's what our tool does for you. It allows you to interact with AI to build a workflow whenever a problem happens. And it can execute that workflow again and again every time there is an alert of similar kind. It gathers a lot of information. All the troubleshooting information is kept in the ticket. So by the time a user gets to the ticket to resolve that issue, they have all the information at their fingertips. They don't need to execute these debugging steps again and again. This demo, please let us know what you think about this tool and if there is a use for a tool like this in your organization, in your own environment. Thank you for watching.